In this video, we want to solve the system 2x minus 3y plus z equals negative 1, x plus 2y minus 3z equals negative 4, and 5x minus y minus z equals 3 with Gauss-Jordan elimination. So recall that this means that we need 1s in the diagonals, 0s above and below those 1s. We first begin with our augmented matrix, which is 2, negative 3, 1, negative 1, 1, 2, negative 3, negative 4, 5, negative 1, negative 1, 3. Our first goal is to get a 1 in the first row, first column. I see that there's a 1 in the second row, first column, so I can interchange those rows to get a 1 in the position that I need it. So we're going to interchange rows 1 and 2. So we'll have 1, 2, negative 3, and negative 4 in the first row. Then 2, negative 3, 1, and negative 1 in the second row. The third row remains 5, negative 1, and 3. So now that I have a 1, I need to get zeros beneath it. And to do that, I can add multiples of the first row to rows 2 and 3. So if I have a 2 in the second row, first column, I can add a negative 2 to that. So I want to do a negative 2 times row 1 plus row 2 and replace row 2 with those entries. So negative 2 times row 1 is going to be a negative 2. Negative 2 times 2 is negative 4. Negative 2 times negative 3 is 6. And negative 2 times negative 4 is going to be 8. And now I'm going to add those to the second row. Negative 2 plus 2 is 0. Negative 4 plus negative 3 is negative 7. 6 plus 1 is 7. And 8 plus negative 1 is 7. Now for the third row, I need to add a negative 5 to 5 to get a 0. So I'm going to have to do negative 5 times row 1 plus row 3, and that's going to replace row 3. So let's see, what is negative 5 times row 1? Negative 5 times 1 is negative 5. Negative 5 times 2 is negative 10. Negative 5 times negative 3 is positive 15. And negative 5 times negative 4 is positive 20. You can see it's really easy to make a mistake. If one number's off, then this whole thing is off. So now I'm going to add those to the third row entries. So negative 5 plus 5 is 0. Negative 10 plus negative 1 is negative 11. 15 plus negative 1 is 14. And 20 plus 3 is 23. So I have a 1 with zeros below it. Now I need to get a 1 in this second row, second column. And notice that each of these entries is divisible by 7. So I'm going to divide each element there by negative 7 to make a 1 in the leading position. Okay, so my first row stays 1, 2, negative 3, negative 4, excuse me. And if I multiply row 2 by negative 1/7, so I'm going to get 0, and then 1, negative 1, negative 1. And row 3 will stay 0, negative 11, 14, and 23. So I have a 1 in the first row, first column, zeros below it. A 1 in the second row, second column, I need a 0 below it. So to get a 0 below it, I'm going to have to add 11 to negative 11. So my first and second rows will stay the same. And now I'm going to add 11 times row 2 plus row 3 to get row 3. And hopefully you understand. The reason I do that is where I have a 0 position. When I multiply something by 0 and add it to 0, I'm not changing it, right? I don't want to get rid of the 0 that I already have there. So if I'm multiplying row 2 by 11, let me just squeeze these numbers in. I'm going to get 11 times 1, well, 11 times 0 is 0. 11 times 1 is 11. 11 times negative 1 is negative 11, and then negative 11 again. So whenever I add those entries, I get 0. 11 plus negative 11 is 0. 14 plus negative 11 is 3. And 23 minus 11 is 12. So 1, 0 is below it, 1 is 0 below it. Now I need to get a 1 in the third row, third column, and I can do that by dividing each of those entries by 3. So my first row is 1, 2, negative 3, negative 4, 0, 1, negative 1, negative 1. And I do 1/3 times row 3, and that gives me 1/3 times 0 is 0, 0, 1/3 times 3 is 1, 1/3 times 12 is 4. Now, again, I could stop if I was just doing Gaussian elimination, but since I'm doing Gauss-Jordan, I have to get a 1 on the diagonals, 0's below it, and 0's above it. So now I need to get 0's above that. So I have to add, to negative 1, I have to add a 1. So let's think about this. So now, my third row is going to stay the same, and I'm going to use it to get 0's above. So I'm going to get a 1 in this second row, third column. So I'm going to add row 3 to row 2 and replace row 2. Because what will that be? 0 plus 0 is 0. 1 plus 0 is 1. Negative 1 plus 1 is 0. And then negative 1 plus 4 is 3. So now I also need to get a 0 in this position with negative 3. And so I add 3 to that. So now I'm going to have to do 3 times row 3 and add it to row 1 to get row 1. So let's see, 3 times row 3 is going to be 0, 0, 3, and then 3 times 4 is 12. So I'm going to add those entries to row 1. 0 plus 1 is 1. 0 plus 2 is 2. 3 plus negative 3 is 0. And then what is this? 12 plus negative 4 is 8. So now, what do I need? I need to get a 0 above this 1. So to get a 0 above the 1, I'm going to add negative 2 to that. So my last two rows stay the same. So I need to do, what did I just say? Negative 2 times row 2 plus row 1, and that will give me a new row 1. So let's see what that is. A negative 2 times row 1, I'm sorry, negative 2 times row 2, it's going to be 0, negative 2, 0, and 3 times negative 2 is negative 6. So when I add those to row 1 entries, I get 1 plus 0 is 1. 2 plus negative 2 is 0. 0 plus 0 is 0. And 8 plus negative 6 is 2. So now I have it in the form of reduced row echelon form. The equivalent system is just x equals 2, y equals 3, and z equals 4. So the solution of this system is 2, 3, 4.